So let's do something about encapsulation now. So I get asked these questions pretty frequently. One is, hey, we don't need to be using Geneve encapsulation in our deployment. Is there a way that we can just not use it? Then the other one is, I want encapsulation, but I've heard Geneve is slow. Is there some way we can use VXLAN instead? So I'm going to sort of talk through this a little bit. So OVN currently uses Geneve or STT in order to communicate between hypervisors, and it can use VXLAN when communicating with a gateway. So obviously, if you're not familiar with what encapsulation is, it's a way of allowing for communication between nodes in an overlay network without any sort of knowledge of what the topology of the underlying network is. So let's go through just what happens in OVN when a packet arrives. So in this list here, you'll see that I say that OVN does things. That's sort of shorthand for saying that OVN programs OVS to do these things. So when a packet arrives on a virtual interface, OVN is able to just tell from the OpenFlow port what the logical ingress and logical data path are. So OVS runs the ingress pipeline, and from that is able to determine what the logical output port is. And if the logical output port is on the local hypervisor, then OVN just runs the egress pipeline and outputs the packet. Pretty simple. But if it's on a remote hypervisor, then OVN has to encapsulate the packet and send it to the remote hypervisor. So what's in this encapsulation? Well, there's 55 bits of data, a 24-bit logical data path identifier, 15-bit logical input port, and 16-bit logical output port. So Geneve and STT have the space within their headers to be able to just embed this information. With VXLAN, you only have a 24-bit field, so we only use VXLAN when communicating with gateways and only encode the data path identifier. So the process on the remote hypervisor is when a packet arrives on the tunnel, so Geneve and STT, they unpack that included data, the metadata, the logical input port, the logical data path, and logical output port, and they're able to run the egress pipeline of the logical data path and output the packet. Done. For VXLAN, on the other hand, it's only able to get the data path, so it has to rerun the ingress pipeline in order to figure out the logical output port. And from there, it can run the egress pipeline and output the packet. So if you don't want encapsulation, OVN does have something that you can use right now. It's something called a local net port. What it does is it provides a link between your virtual network and your physical network, and you can even associate a VLAN tag with it too, so that OVN will put that VLAN tag on output packets and inspect the input packets to make sure that VLAN tag is present. So the problem with local net is you can only have one per hypervisor, and you can only have it associated with one logical switch. So the question is, can you just have native encapsulation-free hypervisor-to-hypervisor traffic? Well, when you remove encapsulation, you're removing a lot of capabilities. So for one thing, you're kind of fundamentally breaking what OVN is meant to do. You're not really supposed to be mixing virtual and physical on the same bridge. There's security implications, just because you are opening up this virtual network to a physical network, to traffic from the physical network, that is. And without encapsulation metadata present, you have to come up with alternative, I called it dubious means in this slide, to figure out the input port and data path. And also, without encapsulation, OVN has to be an underlay network, and it also affects potentially the topology of the network that you're working with. So what's a way you could possibly do it? Well, one way is you could look at the source address and source Ethernet address and say, well, we can try to determine the input port and data path based on that. Unfortunately, I don't like that. I don't think it's very secure. Also, when you have things like NAT that are disguising sources, then you may find yourself in a position where this won't work. But there could be some closed environments where maybe this would work. Maybe it would be valid. Another way you could do it is you have a dedicated port on each data path, sort of like a local net port, but you would have to have a secondary bridge that's smart enough to know how to route the packets from the physical bridge into the virtual bridge. And that, again, that could be a workable solution. I'm going to skip this slide because I don't even really remember what it's about. So then we go on to VXLAN as a solution. So VXLAN, you're really limiting yourself. So one idea you have is just, okay, I can't put as many bits into VXLAN. Maybe I can just, I don't know, have a restriction on a smaller network. But the problem is, if you do something like that, you're going to break more than just the ability to have a large network. For instance, multicast port numbers are in a high number that you almost wouldn't be able to express on VXLAN if you're also using bits for data path as well. So there's also another idea, a little bit, again, dubious, is what if instead of encapsulating the data path in VXLAN, you encapsulate the logical output port? And the idea being that whatever is the initial hypervisor that receives your packet, you run all logical ingress and egress pipelines there, and once you have done all that and you know the logical output port, you encapsulate that and send it over VXLAN to the correct remote hypervisor. The problem with that is it requires having identical OpenFlow installed everywhere, so that's also not very scalable. So my conclusion, let's just say, I'll just read this one line. The best solution is to get rid of negative press surrounding Geneve and prove that it's just as good to use as VXLAN. Or maybe have someone more clever than me come up with ideas. Anyway, that's it.
All right, let's thank our speaker. He packed a lot of info into 10 minutes.